My name is Hamza Javaid, and today I'll record the lecture of basic mechanical engineering course, which I will talk in fall 2024 for the student of electrical engineering department. The topic of my today lecture was heat exchanger. So heat exchanger is a device specifically designed to transfer heat from one fluid to another without letting the two fluids mix. This makes heat exchanger a cornerstone of thermal engineering, unlike basically a mixing chamber which blend fluids together. So heat exchanger maintain the separation of fluids, ensuring that their individual properties are not altered during heat transfer. So it is the basic definition of heat exchanger, that it was different from the mixing chamber. So heat exchanger have broad application across many industry due to their efficiency and functionality. So broadly, there was written that heat exchanger might be used in heating and air conditioning system. In HVAC, basically it was HVAC system, which was heat ventilating and air conditioning system. So heat exchanger play a key role in maintaining comfortable indoor climates by either heating or cooling air based on seasonal demand. So it is also used in power plants. So they are essential in processes like steam generation, waste heat recovery, and maintaining a turbine efficiency. So it was also used in chemical processing. So precise control of reaction temperature is crucial in industries like petrochemicals and pharmaceutical, where heat exchanger enable effective thermal management. So it was also used in waste heat recovery. So industry like cement industry, Fuji fertilizer, and some other industry, so they require heat exchanger for the waste heat to recover. So industries often realize significant heat in exhaust gases by using heat exchanger. This energy can be captured and reused, so increasing energy efficiencies and reducing operational cost. So in short, heat exchanger help optimize energy usage, improve process efficiency, and contribute to sustainable engineering solution. So the classification of this heat exchanger was divided in two categories, which was dependent flow arrangement and another was type of construction. So flow arrangement was this referred to relative movement of fluid within the heat exchanger, either in parallel flow direction, either in counter flow, and some other flow configuration, which was cross flow. So in parallel flow, in this arrangement, both fluid enter the exchanger from the same end and flow parallel to each other. This setup result in lower heat transfer efficiency as a temperature difference temperature difference between mm, between as the temperature difference between the fluids decreases along their path. So in another configuration was counterflow configuration. So here the fluids flow in opposite direction, allowing for a more uniform temperature gradient. This is the most efficient arrangement because it maximizes heat transfer by maintaining a higher temperature difference throughout the exchanger. So another configuration was flow configuration was cross flow. So the fluid move perpendicular to one another in a cross flow configuration. This arrangement is common in situations where one fluid needs to be cooled by air, such as in radiators or cooling towers. So another classification was a type of construction. So this classification depend on the physical design of heat exchanger, including types like shallow tube, compact, and plate heat exchanger. Each design is tailored for specific industrial applications based on factors such as variable space, operating condition, and desired efficiency. So here we have seen that the type of heat exchanger was one type was concentric tube, and some in some book it was written as double pipe heat exchanger. So here we have seen that the hot fluid will move in this inner pipe and the cold fluid will move in outer pipe. It was in parallel flow configuration because both fluid will flow in same direction. And similarly, in this figure, we have seen that the hot fluid will move in this inner pipe and the cold fluid will move in outer pipe, but opposite to each other. It was a counter flow. So the concentric tube or double pipe heat exchanger is one of the simplest design, comprising two concentric pipes, one inside the other. So it was basically a parallel flow configuration. Here we have seen that both fluid into the exchanger from the same end and flow parallel to each other. This is straightforward to implement but less efficient as the temperature difference between the two fluid decreases along their length. So here we have seen that it was a counterflow arrangement, so the fluid flow in opposite directions, allowing for better heat transfer. Here, the existing fluid temperature can be closer to each other than in parallel flow. So basically, counterflow is often preferred because of its higher efficiency. So this type is typically used in application where simplicity and ease of maintenance are more important than achieving maximum efficiency, such as in low capacity industrial processes or laboratory sometime experiment. So here we have seen that another type was a cross flow heat exchanger. So in cross flow heat exchanger, the fluid moved in perpendicular to each other. So in cross flow heat exchanger, the two fluids flow perpendicular to each other. So this design is commonly found in applications requiring compactness and efficiency, such as air-cooled heat exchangers and automotive radiators. So there are two variations of cross flow heat exchanger. One was unmixed cross flow. Here we have seen that both fluid unmixed. So in this configuration, at least one of the fluid is confined within a set path like tubes or fin and does not mix with itself as it flows. So it was here we have seen one fluid mix and one fluid unmixed. So here one of the fluids such as air is free to mix within its channel, increasing heat transfer at the cost of some efficiency. So basically a cross flow heat exchanger are especially useful when there is a need to cool or heat large volume of air or gas. So that's all about the cross flow heat exchanger. So next, basically, I'll discuss another type of heat exchanger, which was a shell and tube heat exchanger. So here we have seen that there are multiple tubes present in between this outer filaments, which was called as shell. So the shell and tube heat exchanger is one of the most versatile and widely used design. It consists of a series of tubes inside a cylindrical shell. One fluid flow through the tubes. Here we have seen that one fluid flow through the tubes while the other fluid flow around them within the shell. So pass design, here we have seen that the term pass refer to how many time a fluid flow through the heat exchanger. So it was one shell and two tube pass, another one which was two shell pass and four tube pass. So here we have seen that it was one shell pass and two tube pass. In this design, the shell side fluid flow once, while the tube side fluid flow twice through the system. Yeah, this increased efficiency by providing more surface area for heat transfer. So it was basically a two shell passes and four tube passes. So this configuration further enhances efficiency and is used for processes requiring significant heat transfer over smaller space constraint. So shell and tube heat exchanger are employed in industries like oil refineries, power plant, and chemical manufacturing, where high pressure, high temperature application are common. So another type of heat exchanger was a compact heat exchanger. So here we have seen that compact heat exchangers are designed to achieve high efficiency in applications with limited space. They provide a high surface area to volume ratio, they which enhances heat transfer. Some key feature of compact heat exchanger include it was lightweight and small size, making them ideal for transportation and aerospace applications. High efficiency due to large surface area for heat transfer, commonly used in basically automotive radiators, air conditioning unit, and electronic device cooling. So compact heat exchangers are particularly valuable in industry where minimizing space and weight without compromising performance is critical. So there was some factor in some disadvantages in this heat exchanger that after some time of usage, there was a falling occur in this heat exchanger. So here we have seen that the falling refers to the deposition of unwanted materials such as scale, rust, or impurities on the heat exchanger surfaces. This reduced heat transfer efficiencies and increased energy consumption. So the fouling factor is a measure of additional thermal resistance caused by these deposit. So the factor affecting fouling include operating temperature. Higher temperature can accelerate fouling due to increase reaction rates or thermal degradation of the fluid. Another factor was falling fluid velocity. So low velocity allow impurities to settle more easily, leading to falling. Another one was length of service of heat exchanger. So over time, the accumulation of deposit become inevitable without proper maintenance. To mitigate this fouling, industrial implement cleaning protocol, use advanced coatings on surfaces and select fluids with fewer impurities. Fouling control is basically essential for maintaining the efficiency and longevity of heat exchanger. So, the conclusion of this complete lecture was, in conclusion, basically the heat exchanger are indispensable component in numerous industrial and domestic application, playing a vital role in efficient energy management and thermal system performance. So, basically, I'll summarize some key point, which was what was heat exchanger. So, heat exchanger facilitate the transfer of thermal energy between the two fluids without mixing them. This characterization makes them versatile in essential industries ranging from power generation to waste heat recovery. So the application of the heat exchanger was there fundamental in HVAC system for temperature control, power plant for energy conversion, chemical processing for precise reaction management, and waste heat recovery for energy efficiency. So the classification I'll already discussed. Heat exchanger can be categorized based on flow arrangements like parallel flow, counter flow, and crossover by constructing types such as shell and tube, compact, or concentric tube design. Each category has specific advantages tailored for different operational designs. So design variant include concentric tube heat exchanger, a shell and tube heat exchanger, compact heat exchanger. So compact heat exchanger basically maximize efficiency while minimizing the space widely utilized in aerospace and automotive sectors. Fouling and maintenance include while fouling possess a challenge by reducing efficiency, understanding the fouling factor, and implementing regular cleaning and maintenance can significantly extend the life and performance of a heat exchanger. So, heat exchanger are the heart of this sustainability and energy conversion efforts by recovering waste heat, reducing energy consumption, and optimizing industrial processes. They contribute to reducing the carbon footprint of industries as technology advances. Heat exchanger designs continue to evolve, becoming more compact, efficient, and environmentally friendly. So that's all about some brief introduction of heat exchanger. What are the type of heat exchanger? What are different classification of heat exchanger depending upon flow arrangement, construction. What was also the disadvantage of this heat exchanger, like after some time it was a falling occur. So there are I'll explain some more in that how the heat exchange in this between hot and cool food. So there is a mode of heat transfer which was a conduction and convection. So here we have seen that there is boundary difference between cold fluid and hot fluid. So they basically do not mix. So at the boundary, there will conduction occur and fluid will also move. So and that mode of heat transfer was basically a convection. So that's all about the brief introduction of this heat exchanger. So thank you for your patience and uh, end this basically a lecture. So that's all about the lecture.